Yeah, so this question is all about pressure, right? So let's see what is given in the question. I hope you have read the question very thoroughly, and let's quickly pick out the data. So what you see is a mercury column where the height of the mercury is given as 76 centimeter of Hg. That's mercury, right? And we are very used to hear 760 mm of Hg, right? So you should know the conversion. Centimeter to millimeter. You know, 1 centimeter is nothing but 10 millimeter, right? So if you say 76 centimeter, that's exactly equal to 760 mm of Hg. Fine, perfectly fine. A very important word is there. The balance atmospheric pressure. That means we are talking about two liquids here. One is mercury, another is an unknown liquid. You have to balance the pressure, the atmospheric pressure. That means the pressure has to be equal. So, you know the formula of pressure, the general formula. I'm not jumping onto the right formula which we have to use in this question. You know, the general formula for pressure is force per unit area, right? Let's quickly calculate, let's quickly derive the actual formula that we have to use from this general formula, and then you can memorize it. In the exam, you're going to use the formula directly, right? Okay. So force per unit area, you have, what do you have? You have density, right? So I have to somehow convert this formula of pressure in terms of density. Okay, let's do that. Can I just write force as mass into G? That's divided by area, right? So I want density. Density is mass by volume. I have mass by area. So if I just multiply area with height in the denominator as well as in the numerator, nothing is going to change much, right? Okay. Okay. Can I write area into height? This term as volume. So can I just write it as mass by volume into height? Make sense? Okay. This is your pressure. Now mass by volume is density. Okay. And of course, G is there, right? Okay. So this will be your density. So can I just write it as pressure is equal to density rho into G into H. And if you remember, pressure, we used to call pressure as rho GH or H rho G, right? That's what the formula is. And the question says you have to balance the pressure of this liquid who has the density as 1.2 gram per centimeter cube with atmospheric pressure. And the atmospheric pressure in terms of height of the mercury column is given as 76 centimeter of Hg. Let's write the final formula. Pressure 1 is equal to pressure 2. I'll call 1 as Hg and 2 as the another liquid. So can I write P1 as rho 1 G into H1 is of course the gravitational constant. So rho 2 into G into H2. So G is a constant, will get cancelled from both the sides, right? Okay. Okay. Now if I call 1 as Hg and 2 as another liquid, I want the density of mercury, the height of the mercury, the density of the another liquid and height of another liquid will be calculated very easily. Let's look at this. So the density of the mercury given to you is 13600 kg per meter cube. Now let's do one thing. I hope you got perfect idea of the question. Let's give it a rating, right? The rating will be in terms of star. If it is a single star, you'll call it a very easy question. If it is a double star, you'll call it an easy question. If it is, or double star will be a moderate question. If it is a triple star, you'll call it as a difficult question. So for this particular question, I would like to give 2.5 stars, right? The chances of error are high. It is difficult to interpret the question. So this is a 2.5 star question in terms of difficulty level. Now if you want to place the density, always remember what unit of density you are keeping it here on the left hand side of the equal to, same unit has to be on the right hand side. Same goes for height, right? Okay. So it is like 136 kg per meter cube. I want to convert this density in gram per centimeter cube. Why? Because my ρ2, density of another liquid, is 1.2 g per cc, right? So kg per meter cube. Okay. Let's use the conversion. 13600 kilogram into gram. Yes. What is going to be? 1000. 10 to the power 3 grams. Okay. Meter cube into centimeter cube. 1 meter is 10 to the power 2 centimeter, right? So 1 meter cube will be 10 to the power 2 whole thrice centimeter cube. That makes it 10 to the power 6 cc. If you just cancel it, 3, and this will be like 2 zeros with this. So 136 by 10 will be nothing but 13.6 gram per centimeter cube, right? Let's put this value. So 13.6 into H1, that is 76 centimeters. See, let's look at the options once. Every answer, every option is in centimeters. So I'll try to keep my height in centimeter to avoid further conversions, right? So this is 76 centimeter equal to ρ2, that is 1.2, right? That's 1.2 gram per centimeter cube. No need to convert this. We have already converted the density of Hg in gram per centimeter cube. This 13.6. You can see this here, right? Okay, cool. Into H2, that's what we need to calculate. Okay. So if I just write H2 will be nothing but 13.6 into 76 upon 1.2. Cool. Okay. So if I just cancel it out, decimal with decimal, can I cancel it with 4? Yes. 4 into 3 is 12. 4 into 19 is 76. 4 into 20 is like 80. So 76 will be 19. So 136 into 19 by 3. If I just cancel this with 3, or let me do one thing. 136, 20 minus 1 by 3. That will ease out the calculation. So 0, 6 to 12, 3 to 6, 7, 2, 1, 2 minus 136 divided by 3. Okay. So if I just subtract this, 2720 minus 136 divided by 3. So this is going to like 10, 6, 4, right? 11, 3. 11, 3 is 8. 6, 1 is 5. 2, 5, 8, 4 by 3. And this is like what? 8, 3, 24. And 18, 6, 4, 1.33 centimeter. 861.3 centimeter. Let's look at the options. 861.3 centimeter is D for Delhi. So D for Delhi is going to be the right answer to this question. And you can see this is a bit lengthy, good calculation. That's why 2.5 star. I hope you enjoyed the question. Alright, so here we have a question from the chemical equilibrium, and we are talking about a reaction, the dissociation reaction, where PCl5 is getting dissociated into PCl3 and Cl2, right? You have seen this reaction a number of times, and we are going to talk about the equilibrium constant, right? Okay, some data is given. Let me write the reaction first. PCl5 going into PCl3 plus Cl2, and what is given is 2 moles of PCl5 was taken initially, right? Let's do one thing. Let's generalize the question, and then finally we will put the data, right? Okay. So if I say initially I have 1 mole, right? And PCl3 and Cl2 were 0. They were not present in the container. The dissociated part, let's say it is alpha. Okay. So if you read the stoichiometry, it is 1 mole PCl5 going to dissociate and form 1 mole Cl2 and 1 mole PCl3. So if alpha dissociated, alpha will be formed for PCl3 and Cl2. Okay, cool. If it is 1, then it is alpha. If it is C, then it will be C alpha. Unitary method, right? Okay, C alpha. Cool. If initially C was present, C alpha got dissociated, So the left amount at equilibrium, right? We are very much concerned about the concentration of all these three, PCl5, PCl3 and Cl2 at equilibrium. Why? Because equilibrium constant of the reaction has to be calculated, and that needs the concentration at equilibrium, right? Cool, cool. So if C was there, C alpha got dissociated, what is left with is C minus C alpha. Initially it was not there, PCl3 and Cl2, C alpha was formed, and finally we have C alpha, C alpha. If I just write, see, this whole scenario is in terms of moles. That's the catch point. That was the point I was talking about. You miss this 2-liter vessel, you might end up getting the wrong answer. So what you need to do is that this mole term has to be converted into concentration. You'll ask me why? Because in equilibrium constant, what you write is concentration, not moles. So if you need to convert this concentration, this moles into concentration, you have to divide it by volume. You know the molarity. Oh, I'll write it here. The molarity, the formula is moles per unit volume. So if I divide the whole by volume, this will be your concentration term, right? Okay, let's write the Kc for the reaction. This will be concentration of PCl3. How do you write the equilibrium constant? The concentration of product raised to power their stoichiometry divided by the concentration of reactant raised to power their stoichiometry, right? So here the stoichiometry is 1 for all of them. So PCl3 concentration of Cl2 upon concentration of PCl5, right? Okay, cool. So if I just see that the value of C given is 2 moles, the value of volume given is 2 liter. So and the alpha is 40%, right? Your alpha is 40%, so alpha will become 0.4. In terms of fraction, it will be 0.4. In terms of percentage, when you calculate it out of 100, that becomes 40%, right? Cool. So let's put the value. If I just put the value, C, I'll take C common, 1 minus alpha upon volume. So for PCl5, this will become, C is like what? 2, 1 minus 0.4 whole divided by 2. This is for the concentration of PCl5 at equilibrium, right? If I do it for PCl3, this will be like 2 into 0.4 divided by 2. Same as for Cl2, 2 into 0.4 divided by 2. 2 will get cancelled. Numerator, denominator, numerator, denominator. Okay. 1 minus 0.4, write it, will be like what? 1 minus 0.4 is 0.6 and PCl3 is 0.4, Cl2 is 0.4, and you have to solve this. This will be like decimal, 4 by 6, 2 by 3 into 0.4. I'll write it as 4 into 2, 8, 0.8 by 3, 3 to 6, 20, 6, 18.267. And what will be the unit? See, this is concentration, cancel. I am not cancelling Cl2 with PCl5. I am cancelling the concentration of Cl2. No, the unit of Cl2 with PCl5. So what will be left is the only unit of concentration of PCl3. So that will be like what? Mole by liter. So the final answer to this question should be 0.267 mole per liter. Let's look at the options. 0.267. Oh, let me just clear it. Otherwise, you'll get confused. 0.267 mole per liter. That's B for BYJU'S or B for Basir. That's my name. So B is the right answer. Thank you. Alright, so here we have an amazing question from thermochemistry, right? And there is an equation given to you. That's the combustion of benzene and some data with that. What you need to find is the delta H naught formation for benzene, right? Okay. The important part. This is the heat of the reaction that is liberated. And when the heat is liberated, the sign of the delta H becomes negative. The reaction becomes exothermic, right? Okay. So let's write the delta H naught of reaction in terms of enthalpy of formation, right? And that is going to be what? Product minus reactant. Let me write that. Summation of delta H naught formation of product minus summation of delta H naught formation of reactant. What do you have on the product side? You have 6 CO2. So 6 into delta H naught formation of CO2, right? Okay. You have 3 water molecules. So plus 3 into delta H naught formation of water. Don't worry, you have all the data, right? You have read the question. Minus delta H naught formation of reactant summation, right? So what do you have on the reactant side? You have benzene, that is 1 mole. You have taken 1 mole of benzene and you have 15 by 2 moles of oxygen gas. Okay. So if I just write delta H naught formation of benzene C6H6 plus 15 by 2 into delta H naught formation of oxygen. Okay, let me first write it, then I'll talk about it. Cool, that's the whole formula. In this, you have 1, 2, 3, 4, 5. 5 parameters. Out of those, 1, 2, 3. 3 are given to you. 1 you need to calculate. That's the delta H naught formation of benzene. But what about this delta H naught formation of oxygen? That is neither given nor being asked. So there has to be some trick for that, right? Now remember that the delta H naught formation of most stable elemental state, that is for reference taken as 0, right? So delta H naught formation of oxygen is going to be nothing but 0. So the problem solved, and this goes 0, right? Okay, this is cool. So if I just put all the values with the sign convention, right? 3267, okay? So this will be like minus 3267, and let's look at the unit as well. So the unit is kilojoule, and because we are talking about 1 mole, so the unit will become kilojoule per mole. So now if you want to rate this question out of 3 star, 3 star is for like difficult, 2 star is like moderate question, and 1 star is for easy. So I'll call it a 2 star question. Although it is not moderate, it is an easy question, but the calculation part makes it a moderate question, right? Okay, cool. So if I just put the values for CO2, what is given is minus 393.5 kilojoule per mole. Okay, okay. So is equal to 6 into minus 393.5 kilojoule per mole. Okay, you have 3 water molecules. So plus 3 into, what do you have? The data for water. The data for water is minus 285.83 kilojoule per mole. Okay, okay. Minus 285.83 kilojoule per mole. That's what is given. Minus, let's assume the enthalpy of formation of benzene as X. That's what we need to calculate. Plus 0. 15 by 2 into 0 is 0 again. Okay. So we need to solve this. Good calculation, lengthy calculation. That's why it is a 2 star question. Okay. So if I just solve this, minus 3267 is equal to 6, 530, 0, 3, 6, 3, 18, 3, 21, 2, 9, 6, 54, 56, 5, 6, 3, 18, 23. Minus 2361 kilojoule per mole. Minus, let me take this minus sign out, multiply this with 3, 339, 8, 3, 24, 2, 5, 3, 15, 17, 8, 3, 24, 25, 2, 3, 2, 6, 7, 8, minus X, right? We have to solve for this. So let me take X on this side, and if I just add this part, and this will be like what? 857.49. Add this, 49, 7, 8, 6, 5, 11, 9, 3, 12, 3. Okay, okay. plus 3267. Wonderful, wonderful. Okay, okay. So this is like what? If I just solve this, 3267.00 subtracting 3218.49. You have to be careful with the calculation, right? You cannot take approximation. See, the options are really close, right? So 10, 9, 1, 9, 4, 5, 16, 8, 8, 8.51, 8.51. Okay, okay. So this is like what? 16, 8, 8 and 5, 1, 4. 32, 32, cancel. 48.51 with a negative sign or a positive sign? Of course, the positive sign. So D for Delhi, 48.51 kilojoule per mole is going to be the right answer to this question. And with that, we close this question. Thank you. So here we have a question from the chemical equilibrium part and something related with the Kc and Qc, right? Okay. So what you are given with is the Kc value, the equilibrium constant value at 400 degrees C, right? This is the equation, P4 dissociating into two P2 molecules. Cool. Okay. Now you have the initial values for the moles of P4 and the moles of P2. Okay. You have to calculate the QC, the reaction quotient. Okay. You know, what is the difference between QC and Kc? The formula is more or less same. The only difference is QC at equilibrium is known as Kc, right? Whenever the concentration is at equilibrium, you'll call it Kc. When it is not at equilibrium, you'll call it QC, right? Okay, so if I just write the QC for this particular reaction, I'll write the concentration of product raised to the power its stoichiometry divided by the concentration of reactant raised to power its stoichiometry. Okay, so if I just write P2 here, and because the stoichiometry is 2, so it will be raised to power 2 divided by P4 and the stoichiometry is 1, so raised to power 1. Perfect. So what you are given is the concentration of P2. One important part. This 2 mole and 3 mole is not concentration. It is the moles, right? It is the amount. The concentration, the molarity, formula for molarity is moles by volume. So if you forget this 2 liter, you'll get the wrong answer. So if you just rate this question on the level of difficulty 3 star, 2 star or 1 star, I'll call it a 1 star question. That's an easy question, right? Okay, that's a bonus question in exam. So if I just write the concentration for P2, the moles are 2, the volume is 2 raised to the power 2 upon, for P4, the moles are 3, the volume is 2 raised to the power 1. Cool. So 2 to get cancelled, 1 square is 1 upon 3 by 2. 2 will go in the numerator. Final answer will be nothing but 2 by 3. And that's what I see in option B. B for Bombay or B for BYJU'S or even B for Basir is going to be the right answer to this question. Thank you. Alright, so here we are going to talk about in this question about the buffer solution, right? One statement I always say whenever I talk about buffer solution, and that is that in buffer solution, weak is strong. That seems to be an oxymoron, right? Weak is strong. What do I mean by that? Let's take the philosophy. If you want to be strong in your life, you have to work hard, you have to work more, you have to be more active, right? So that's what I mean by weak is strong. In buffer solution, weak is more active. Weak is playing the central role. Weak is very important, right? So if you define buffer solution in general, what I say is buffer solution is a weak acid. It's a combination of weak acid plus the salt of the same weak acid. What do I mean by that? Understand with an example. See, what I have written in terms of acid, you can write exactly the same definition in terms of base as well. What it will be? It will look like weak base in combination with the salt of conjugate of same weak base. Let's understand with an example. Look at the options. Option A, CH3COOH. Tell me, is it like a weak acid or a is it like a weak acid or a strong acid? It's a weak acid, acetic acid, vinegar, you know this, ethanoic acid, and what do you see on the other side is CH3COO minus Na plus. CH3COO minus is a conjugate base of weak acid, acetic acid. So all the conditions are satisfied. Yes, it is a buffer, but not the answer. Why? Because we are looking for a solution which is not a buffer solution. Cool. HCl, NaCl. What about HCl? Weak or strong? Of course, it is a strong acid. So, and you have the conjugate part Cl minus. But buffer is all about the weak part, the weak acid, the weak base. This is not a buffer solution. Could be the probable answer, right? Okay. Next option C is HCOH, the formic acid. The organic acids are generally weak. Okay. So HCOH and you have HCOO minus Na plus. Again, you have the conjugate base of the weak acid. It's salt. So yes, it is a buffer solution, but not the right answer. Next, if I ask you, give me an example of a weak base, the very first answer from most of you will be ammonium hydroxide, NH4OH. So NH4OH is a weak base. Ammonium chloride, NH4 plus Cl minus. You have a weak base. You have a salt of the conjugate of the weak base. Okay, cool. Both the conditions are satisfied. You have the weak base. You have the conjugate part. Yes, it is a buffer solution and not the answer. So B for Bombay or B for BYJU'S or even B for Basir is going to be the right answer to this question. And with that, we close this question. Thank you.